All right, so may I have everybody's attention, please? What we are talking about is a few things about this simple network that we just created. And I have sort of listed out things here that I want to talk about. And obviously, if you have any questions, let me know. But the idea is that I'm going to go over these things, if you can pay attention here, and make sure that your network meets all of these requirements. And also, like, it's not just about the checking off of the assignment, but it's also about making sure that, there are some, tips and tricks that I'm using that I sort of make you aware of. And then obviously this is all practice related. So if you work more on it, you will learn more of these tricks and so forth. So, and thank you, Dana, for providing your network for sort of doing this. So one thing that you could do, and this is something that, this introduced in the newer versions of it, they used to have like a speeding up of the network. So this little icon here, so I should probably annotate this with a spotlight. So if you look at this little icon here, that icon represents a fast mode. So if you click on this, the network runs in like seconds. Okay. There used to be a thing in the simulation tab under parameters. You could, simulation speed maximum, but this fast mode is even faster than the maximum. I don't know how that works, but they call it maximum here, but then this one runs even faster than the maximum. So this would be important if you've checked all the behavior of your vehicles and you just want to get the results many times over. Okay. So remember this piece, this little icon here will generate. Now that I have this tab open, the other thing I want to talk about is this random seed. We did not do anything with the random seed for this lab at all, but in your future labs and any real world VISSIM project that you might work on, seed numbers will be very important. Seed numbers make sure if you don't change your network and you use the same seed number, then you get the exact same output from the network. Seed numbers are changed typically to get sort of to capture that day-to-day variation that might happen on a transportation network. So I would you could start with the random seed 42. You can also do number of runs by, so if, typically when we present the results from simulation, we don't just present the results on travel time or delays or anything that we are measuring based on just one run. We don't ever do that. So what we do is usually we'll do the number of runs like 5 or 10, and then every time we'll increment the seed number by 1. You can increment it by 1, 2, 5, 10, whatever you want. That's perfectly fine. But what's important is that number of runs. So how many number of runs you want to do, and VISSIM will do those number of runs automatically for you. If you wanted to average those runs, it will do that for you as well. So this is another sort of important thing when you're working with VISSIM on real projects, because you will need to average out the results on delays or travel time or whatever over certain number of runs. Okay? So that's one more important thing to kind of know. But even though that's not important for this lab, but for future labs, it will be. And then I'll hit OK here for now. And then we can run the network. One thing I wanted to talk about before we sort of run it is this idea of vehicle inputs and vehicle routes. And I mentioned that on Tuesday as well, but because now I'm recording it, I want to make sure that I say it again, is that vehicle input is sort of the input that goes on at the beginning point on the network. Okay, so this is where you should be inputting your vehicles. Okay, and you want to be inputting these vehicles as close to possible, as close to the starting points as possible. Okay, I will never be putting any vehicle input over here, right? There's no vehicle input that is placed on this link. Why? Because this link goes in the other direction. Okay, so I'll put the vehicle input, if it's sort of the normal direction, like eastbound vehicle input, I'll put that here. And then, so if I look at the list here, show list of vehicle inputs. and I can, if I go and show, show entire network. So if I click on this show entire network, I can see the whole network, but then I can also, all these different vehicle inputs sort of get highlighted here. So this vehicle input is the vehicle input from First Avenue. This vehicle input is, you know, so different ones, you can see where those are. And you see this little black thing is basically the vehicle input. So you can move it. And then these vehicle input, and right after the vehicle input, then you can start having the routes. So this vehicle input only decide how many vehicles enter the network every hour. Okay. How many? And so this is 100 means basically 100 per hour. Okay. 60 per hour. So that will be the rate, regardless of what your simulation time horizon is. This vehicle input rate is always in per hour. So that's one thing to remember. So then what's going on with routes? The routes are interesting because if you go to routes, so this is still the vehicle input, but I want to see the list of the route. So I'm doing the static routing. So you can see that the data is numbered is as origin 1 through 6, basically the same zones that we had showed you in that tutorial. I noticed that when you guys were working on it, some of you were working on it, you created sort of, for each origin, you only had like one sort of destination route. But in fact, the way it should work is the way it's shown here, is that you have one input, and then for each input, you have sort of these 5 routes. If I again go to show entire network, and I click on this, if I click on this, this should show me where all those routes are. So do you see? So if I go to the next one, scroll down and go to the next one, this is the second through route. I click on the third one. This is the route that starts here and goes all the way here. So when I'm defining my routes, this is how it should be. For all origins, I should have 5 destination points. I should not have one origin and one destination. So I shouldn't have 30 different origins over here. I don't want 30 over here. I want 6 origins. And for each of those origins, I want 5 routes. That's how you get to those 30 possibilities. Is that clear to you, everybody? Is that how everybody's network looks? If it doesn't look that way, you have to make sure that it does. You should not have 30 origins over here. You should have, and then 30 destinations. No, I want 1 origin or 6 origins here. And then for each of these origins, you should have these 5 routes that define where your routes are leading you. So I can pick any of these. So I can put the number 4. Okay. And then for each of those number 4, I can then say, okay, so number 4 has origin over here. And then if I look at each of these 5 ones, I will see where those routes go. I hope you're seeing the yellow route that gets highlighted every time I move my cursor. So please make sure that this is how your routing is done. It's very important. That's how the routing has to be done. Okay. Questions about this? And then obviously, how much flow goes where is determined. How much flow goes where, I should probably, if I scroll to the right a little bit, I can see the relative flows. And these relative flows, I've mentioned that many times over, that these relative flows are essentially defined. What's the ratio of vehicles that are going to be moving about in those directions from that origin to that towards those destinations? Okay. And it always works proportionately. So they can add up to 100 or they may not add up to 100. It doesn't matter. It's just that the flow will always be divided by what's the relative ratio. So you could have, these numbers could have easily been 1, 1, 1, and then 15 and 2. Okay. As long as they maintain that same ratio, you'll be okay there. Okay. Now, since I'm here, I should probably note one trick that I use if I want to make sure that certain movements are being modeled correctly. One trick that you could use is, let's say, I want to see whether the vehicles that are getting originated here so let's say if I want to see what's happening on this movement that makes a right turn, and I'm interested in evaluating whether they're making the left turn correctly or right turn correctly, or are they running the stop sign, are they running the red light and whatnot. And let's make sure that I'm interested. Let's see if I'm interested in making this left turn from here to here. So I will be interested in, let's say I'm interested in this left turn movement. Okay, the movement that just got highlighted here. I want to see if these left turners are running red light or not. So one trick to do that is, because if your relative flows are low in that movement direction, you will be waiting forever to actually see what's going on. So sometimes, just to check things, you might want to just say, okay, I'm going to just increase this number to a crazy high number, like maybe, and it could be anything, it doesn't matter. You can put whatever you want in here, a really high number, and that high number will make sure that all other movements get almost negligible traffic flow, and that movement gets all the traffic that comes through there. And that will make sure that now when you run the network, all the vehicles will be making that left turn. And then you can easily evaluate if they're running red light or what's going on. I think they're stopping on red light, which is good. You know, it doesn't change the vehicle input. It just changes the relative flow of however cars are coming in. They're all going to turn left. It does not change the vehicle input. If you also want to, if your numbers are low enough, sometimes you can do the same thing by increasing the vehicle input in that direction as well. But you have to be careful, because if you put too much vehicles, then that might cause congestion that might not always be there. So obviously, anytime you do these types of tricks, make sure to change it back to the right number that you wanted. So that's also very important. Don't forget that now you have forced every vehicle to move a left turn or make a left turn from here. And that's a problem. You don't want to do that. Okay. So there's that trick sort of. So this is a trick that I use typically to make sure that all my behaviors are correct and all of that. Let's see. Okay, so checking trick. So the next thing I want to talk about is the warm-up period. And warm-up periods are really important because, as I said in the class, the network starts out with it completely empty of any vehicles at all. Now, obviously, vehicles are what add to the delays and stuff like that. So if you're starting to get your data from the very beginning, you get like some basically points on the data that are based on when the vehicles had very little to no vehicles at all. And that way you will be underestimating the delays in your network if you do not have a warm-up period. So what you want to do is, in your evaluation configuration, when you're configuring your evaluation, you don't want to collect data from starting from time 0. Maybe you want to, it's a small network, so maybe you want to spend like 5 minutes to warm up the network, and you only want to collect the data. And if you have this number as very high number, that basically goes from start to the finish. Okay. But if you want to have sometimes if you have network, sometimes you want to have clearance time as well. So you might want to collect some data into the middle period, and that's perfectly fine too. But I think the most important thing here is the warm-up period. If you have a bigger network, you might want to have as high of a warm-up period as like 15-20 minutes. Okay. But in this case, 5 minutes is probably more than enough, okay, because the network was too small. So that's one thing. So anytime, and this applies for any of these, any of these outputs that you might be generating. And then direct output is something that I mentioned in the tutorial later, but this is something that you use then to save the data to an output file. Okay, and this applies to anything. The delays data, the signal changes, and SSAM, we won't talk about it until towards the end of the quarter, which is the surrogate safety assessment model. Whatever it is, if you want to write the output to a file, you have to check this box, whatever output you're trying to use. Okay, so if I don't check this box, no output files get created for travel time. But if I check this box, the output file get created. I can do this here, and that's fine. And I can filter out the first 15 minutes in the Excel or in the text file that I'm getting. That's perfectly fine. So that's one more thing about the output. Any questions so far for whatever we've talked about? And then, so overlap. Okay, so this is the last thing I want to talk about before we sort of wrap this discussion up, or second last thing really. So one thing is that the signal discussion that I provided today, it's very simplistic in terms of being only for sort of pre-timed signals. And pre-timed signals are sort of signals that nobody uses anymore. Like, you have, it's not that signals never run pre-time, they do. Anytime signal is coordinated, it runs in a pre-time mode, because you have to provide the right offsets, the constant offsets. So for example, if you're going on Marsh Street or Higuera Street, those signals essentially run in a coordination. And that's essentially pre-time operation. But all the signals are actually designed for actuated operations, because at the night time, what happens is that signal is always green on Marsh Street, and only if there is a side street traffic that signal gets actuated, right? So it's very important for you to learn how to model actuated signal. Unfortunately, this version of VISSIM, to my knowledge, does not provide that functionality. And when you model the signal outputs using VISSIM, or when you input or when you model actuated signals using VISSIM, we create what we call the .rbc file. And I'm going to type that up here. So I'm going to annotate. So for actuated signal, signals are modeled using .rbc file. And let's say you modeled a VISSIM network with actuated signals. So you'll have to create all those RBC files. And when you're sharing your network with somebody, you have to make sure that not only do you take your INTX file and give it to them, you have to give all your RBC files as well. Because RBC is called ring barrier controller, and it's a sort of a different add-on to VISSIM than pre-time signal, which are just built into VISSIM. Okay, so something to consider there is that when you're sharing, and I'll quickly share with you a brief tutorial of RBC signals as well. We won't be able to do it in the class, but you will have it for your reference. If you have the full access to full version of VISSIM, you would be able to use it. Okay, so now last thing I want to talk about, and that brings us back to this lab. And I want to clear all the drawing here. Okay, the last thing I want to talk about this lab is, well, first of all, do you wonder why this simulation keeps running? Why is it still running? What's going on? It should have been run by now, right? It should be. It's been going on since I last ran it. Do you know what happened? No, not the warm-up period. Warm-up period is probably like 5 minutes, 300 seconds, so it shouldn't happen too much. Any other thoughts? Now, does that, anybody get the hint? Because I said run it 5 times. So what it's doing is it's doing 5 runs of the simulation at the same time. And if you, I think if you have the sort of the right things collected, if you look at the evaluation and configuration, sorry. If you look at the evaluation and view results list of travel time, yeah, vehicle travel time results. It's doing it for each run. So you can see that simulation run. That's basically what it's doing. It's for 1 run. And if you come all the way down, it will probably have like number 2, number 3, all of those simulation runs, different simulation runs are being done. Okay, so that's why it's still running. Okay, Last thing, and this is sort of important for you to check it and understand what's going on. You know, the key thing in simulation models is that we are trying to replicate the right behavior as it would occur in the real world situation. Okay. And because we're trying to do that, but the cars that are running around in the VISSIM, obviously they're not driven by human. They are just basically some mathematical model on car following, which we're going to learn next week in the class. And they're just sort of, and then lane change, all these different models are built into it, and they're just following that algorithm. So when you do this, to get them to sort of obey the behavior, you just have to provide the right input. And this is something to be, so then if you have a signal controller, it becomes very important, relatively speaking, where you put the signal head and where you put your stop sign that you're using for right turn on red. Their relative positioning becomes very important to figure out whether or not the behavior that you're getting is correct or not. Okay. So if you look at this one, so this is the right turn connector, this is the left turn connector. My signal head here is located on the main link, but it's right before the left turn connector. But if I stop this run right here and I move the signal head a little bit further up and my left turn connector starts before that, can you predict what would happen when I start running this simulation? Can you predict what would happen now that I've moved the signal head a few feet ahead of where my left turn connector starts? And remember, I think I still have all the movement just going left. Can you predict what happens when I run it? People will not obey, not even may not. They will just not obey because they don't. Because if you are a left turner, you get assigned to this connector as soon as you hit this connector in your path. And as soon as you do that, you just start to run red lights now. So if you look at it here, and there will be vehicles arriving at some point, it wouldn't matter whether the light is red or green, they just run because they already have gotten onto the connector. So obviously, if I want my movement to be controlled by this traffic light, I need to make sure that this light is located before my left turn connector starts. But on the flip side is, I don't necessarily want this red light to control my right turn movement, because I want that to be controlled by the stop sign that I've created for right turn on red. Okay. And for that, your signal head should be located after your right turn connector starts. And then for that situation, you can put your stop sign on the right turn connector. Now, one thing is that you could put your stop sign before that too. It's not necessarily wrong to put your stop sign here, because if you look at the condition of, if Dana has modeled it correctly, if I look at the details of this stop sign, it's right turn on red and it's connected to that signal group. Okay. As long as it's connected to that signal group, it only becomes active when that signal head is red. And obviously you have to make sure that you're connecting it to the right signal head, because you'll have all these options. And I think yeah, this is the one that was. So it's connected. I could place it here. My behavior will still come out correct. Obviously, to observe that behavior, what do I have to do? If I run the simulation now, can I observe whether the right turn on red behavior is correctly being modeled or not? Can I check it? Actually, I won't be able to check it. You know why? Because I have this absurdly high number. Oh, no, not vehicle input. I'm sorry. If I go to because I have this absurdly high number, 90,000 or whatever. So everybody just goes left. So I will not have any opportunity to observe how the right turners are doing, right? So I won't get that opportunity. And so that would be a problem for me. So what I need to do is I need to get that number to be sort of in line with what it was. Probably should be 0.100 or whatever the correct number was. So you correct that. But if you want to see the right turners, you can actually bump up this number this time so that everybody is making the right turn, and then I can observe whether that's going correct or not. Okay, so any questions about where do you put? So always, like, and if you're getting some wrong things in your model and you're not getting the right behavior, always a good idea to kind of play around with the situation or think about it. What type of traffic control is each vehicle encountering as they move forward? Okay, are they encountering the correct thing that I want them to encounter? Or if they're sort of by mistake, they're doing something wrong. Okay, so yes, Vaishnavi. Okay, so is that not correct on the, so let me go ahead and pause the recording here. So the question I was asked is, how do we sort of enter the vehicle travel time information? So you can see that there is 1, 2, and 3 different vehicle travel time measurements that have been added. And then you could see that there are, like, they're all on Main Street. One has an starting point of 0.417 and end point of 499.146. So if I highlight this, this is measuring travel time from this point to this point. Okay. If I click on the second one, I have one white line appear here, and then the second white line appear here. I'm basically measuring travel time from this location all the way to the upstream of this intersection right here. Go to the last one. My starting point is here and my end point is here. Okay. And you can also see it in the endpoints. So start points are very, very close. And endpoints are 499 feet, 1520 feet, and 2014 feet. 2014 feet is approximately the whole length of this link right here. And it only gets you the travel time on going on this direction. So let's say if I want to add another travel time. So I can, so if we go to vehicle travel time. So next, I think you can add and one more. So go ahead, pause the recording one. Resume recording. So let me do one more travel time measurement. How do we? So you have to select first this travel time. And then once you select it, you right click, add new travel time measurement. So this starts my origin point. And let's say I want to go from this point and I'll measure travel time all the way to this point right here. Okay, and I'll click on it. I hit OK. So now this is able to measure the travel time from starting from here, traveling through this link and going all the way up here. Does that answer your question? Okay, perfect. Thank you. Okay, so that's that. Let me pause it. One last thing is that the VISSIM obviously doesn't model collision. VISSIM doesn't allow vehicles to occupy the same space at the same time. That doesn't mean that when the simulation is running, you will never see those things happen. You might actually see them happen. It doesn't look good. It's not right to have that happen. And why does that actually happen is the reason is right here. So if I go to Lincoln connector and I go, let's say zoom into here and let's see. And I want to. So we have modeled these interactions, but you can see that anytime there is an overlap between links and connectors, anytime there are overlaps between links and connectors within VISSIM, those areas have to be managed using conflict areas. And that's what that conflict area basically decides. If you leave those conflict areas as yellows, they will sort of try to negotiate that space. If there is sort of any kind of overlap. Now, sometimes some conflict areas we don't actually manage because we know they're not real conflicts, but just because two links and connectors are coming together at the same time. So for example, one way to think about this is if you have this right turn and then this left turn, this left moving vehicle and this right turning movement. Okay, So I'm showing you two movements, right? So those ones that are on your screen right now. If you think about these movements, in real world, vehicles making a right turn, and from the same direction, vehicle moving the left turn, vehicle making a left turn. Do you think that's a conflicting movement? From the same location, if a vehicle is making a right turn and another vehicle is making a left turn, that generally should not be a conflicting movement, right? Because unless there is a rear end conflict that happens and they crash into each other. But in real world, this should not be a conflicting movement at all between the two. There's no crossing that's happening. So these types of conflicts typically don't have to be managed. But if you make these connectors too long, if the right turn connector or the left turn connectors are pretty long in length, then the right turn and left turn vehicles might seem to occupy, they might visibly look to you as if they are in the same physical space. Even though as far as VISSIM is concerned, one vehicle is on the left turn connector, one vehicle is on the right turn connector. So we never actually manage those conflicts because we assume that because we know there is no real conflict, so we never manage it. But if your size of the length or the length of your connectors are too long, they might appear as if they are occupying the same physical space. And that does not look good. So the tip I have for you is that you should make your connectors as small as possible. Only use the length of the connector that you really need. Don't ever make them too large. Always make them too small, but obviously have the correct spline points, so they provide that smooth maneuvering. Okay. So that's another trick that I tell everybody, that try to keep your connector size small. And then a corollary of that is that if you're modeling this, like for example, this link here is modeled as I would model it, right? This link sort of goes through. I've had some situations where students will draw out the link up to here, and then even for through link, they will use a connector. Okay, and that's not something you want. You want, like, if there is a through link, you want to be able to model that without connector. And may not always be possible because sometimes the number of lanes might be dropping and whatnot. So you might need that, but wherever possible, you model it directly as a through link, and that's good. Okay. Now, one thing I want to show is, let's say if I'm creating another link, right? So I want to add new link, and I want to have link number 7, number of lanes 2. And I hit OK here, and I can drag it out to become a larger link. And then if I click on right click, there is generate opposite directions. Okay, so I got this whole road now built up, right? Now let's say I want to create another road that goes from add new link, and I want to have link 2. Okay, but this time I want link to look like this. Okay, so I want to have it go this way, and I want to create opposite direction to this as well. Okay, so I got these links. I've created these links, and I can input some traffic volumes from here. I can input some traffic volumes to here. But what do you think happens between these two links? How does VISSIM deal with these two links, the traffic between these two links? Would it create any kind of conflicts here? If I were to actually input some traffic and provided the routes going from through, and let's say I only created through routes, just the through movements here, what do you think will happen? Right now, VISSIM will think they're over passive. They're one over the other. Because I have not defined the conflict areas. I have not defined anything like that where the vehicle's paths will intersect. But if I go to potentially, like, once I create the vehicle movements and all that, I need to sort of show VISSIM which link has a priority, or I have to manage that conflict area somehow. It could be used using a signal or whatever. But if I just draw out links like that, they might as well be over passive as far as VISSIM is concerned. Okay, so even if you might see vehicles moving on top of each other, they're actually grade separated, so to speak. Okay, so that's another thing to kind of remember, that if you draw links like that, VISSIM treats them as overpasses or grade separated sort of interaction, unless you sort of start defining what's the conflict areas and how do we manage the conflicts, and that's where VISSIM knows that they're on the same grade level. Okay, so what I'm going to do is, with that, I'm going to stop, and I'm going to trust you guys that your network actually accounts for that. And I see that most of you were engaged with the network. You're working with your VISSIM assignment and so forth. So I'm going to mark all of you done, unless you have any questions about how any of this works. And obviously, it needs practice, and whatever I've told you today, it's not that you will know it throughout the quarter, but I think as you practice more, you'll get more experience, and then you will know those things by heart. So with that said, let's stop the recording.